question.
Hello everyone. Welcome to day 3 of JuliaCon 2021. My name is Saranjit Kaur and I'm moderating this single track session. The conference updates are available on the web app and you can join the conference chat on Discord. All spaces of JuliaCon 2021 are bound by our code of conduct. We would once more like to thank our sponsors Julia Computing, Relational AI, Pumas AI, Conning, Invenia Labs, QEra Computing, Kaust, DataChef, Jeffrey Sarnoff, Packet Publishing, and the Julia Project's fiscal sponsor, NumFocus. Without their support, this conference would not have been possible. Let us begin then. At this session, we will have the last keynote of JuliaCon 2021. I would now like to invite the keynote speaker of the day, Soumith Chintala. Soumith is a researcher at Facebook AI Research, where he works on high performance deep learning. He co created PyTorch, a deep learning framework that has traction amongst researchers. He works on computer vision, robotics, and machine learning systems and holds a master's in computer science from New York University. Just a reminder about the time limit, 40 minutes for the talk with about 5 minutes for the questions later. The audience can ask questions on Discord and we will keep track of those. Over to you, Somit.
Thank you, Saranjit. Hi, everyone. My name is Soumith. I work on PyTorch and I work at Facebook AI. And a few months ago, Viral, who works on Julia, he emailed me saying, hey, Julia invites people to do keynotes from parallel communities to be able to learn something from those communities and how they work. And that was interesting to me because initially when I thought, oh, like, am I keynoting at Julia? Am I supposed to talk about how PyTorch should be implemented in Julia? But that's not really what Viral was going for. So here today, I wanted to give the journey of PyTorch and my journey through open source, and I wanted to build up a framework to try to help other people in open source from the Julia community and beyond in thinking about how to build and grow open source projects. So first, I will give you a little bit of context about PyTorch itself, because I know this is JuliaCon and some of you might not have heard of PyTorch. And then I will actually go through storytelling, where I will actually go through a few areas. So to begin with, PyTorch. What is PyTorch? So to give you a rough overview, PyTorch is an ecosystem, but at its core, it is a library of ND arrays. So you can think of matrices, tensors, and dimensional arrays, combined with an automatic differentiation engine that is deeply embedded within this ND array library. So you can build things like neural networks or PDE solvers and things like that. And then to take these components to the next level, we have a bunch of utilities such as like high performance data loaders and distributed PyTorch, for example, to scale your neural networks or your other scientific computing code to multiple thousands of machines. And finally, we have a just-in-time compiler to optimize PyTorch at runtime to run faster. And all of these are basically running on multiple kinds of hardware as well. So it's not just CPU, but CPU, GPU, TPU, graph core, IPU, and like many other machine learning or scientific computing accelerators power the backend of PyTorch. And at its core, PyTorch has like Py in it, and it's Python fundamentally. But if you look at the implementation, it's largely implemented in C++, mostly for performance, with Python as the front end. And if we would have written it in Julia, obviously we wouldn't have had to separate out the Python and C++. But that's for another day. So again, like to let you internalize like what it actually looks like in code. So the most typical use case for PyTorch is writing neural networks. And the way you write neural networks is you define a class where in the constructor of the class, you define a bunch of learnable layers. And these are like heavy stateful classes that compute something, convolutions, matrix multiplications that have learnable parameters. And then you define the neural network structure as Python code. So the Python code itself is the neural network, and the neural network is the Python code. And all of this is powered by an automatic differentiation library. So just by defining these two parts, you get gradients, and you can do gradient-based optimization. And this code runs on accelerators naturally because the backend abstracts that away. And the general principles we operate PyTorch with as of today is we have four main ones. We want to always enable cutting-edge research. That's a bet we take, and I'll talk about this more later. But at the same time, we want to be performant and production grade. That is there's a strong tension between enabling the latest stuff and giving the stability that production wants. And we sit somewhere in between, the constant tension between these two parameters. And like we think it's critical to keep this tension alive. That is, we can't go too much into just enabling research, or too much into enabling today's stable models, because then you're trading off short-term for long-term, or long-term for short-term. And that's the exploration-exploitation trade-off that you see in, say, reinforcement learning as well. But we have a lot of users in scale, and so we need to be responsible and make sure the overall product is stable. But one thing to keep in mind is, like, yes, we are a large project, a large team, and very well funded by large companies. But still, the amount of breadth that there is to explore, we can't enable everything ourselves, nor do we aim to. That's not even our goal. And we want to like build this future with a bunch of partners and stakeholders and core developers and peripheral library developers. And I think it's also, again, it's similar to how research to production is like this trade-off that's very interesting. Co-developing with many stakeholders in mind is also a very natural regularizer to not believe our own hype or our own bad ideas. And we have an incredible ecosystem of libraries that are within the PyTorch ecosystem that everyone benefits from, and that everyone co-develops with each other. And we also start to play well with the larger Python ecosystem. And we've done a lot of work in trying to standardize our low-level marshalling interfaces and such. So that's like the principles with which we operate in. And as of 2020, I didn't pull the latest stats, but as of like late 2020, we've had about 1,600 contributors, 45,000 used by projects on GitHub, and about 34,000 users on our forums. And every single issue and pull request that is opened on the PyTorch core is read by at least one PyTorch developer. That's a guarantee we've tried to strive for over the years as we scaled, and as of 2020, we are able to do that And I'll talk a little bit about this later as well. And PyTorch, apart from Facebook, who remains the majority funder of PyTorch, there's several other companies who fund PyTorch extremely well. From NVIDIA, who's been with PyTorch since the beginning, to Quansight, who helps power a lot of core development on PyTorch, to Microsoft, who's helped with various things, including the latest program of taking PyTorch to the enterprise and offering enterprise support on PyTorch, to AMD, who's built the PyTorch backend for AMD GPUs, to Google, who has helped with PyTorch for TPUs, who's effectively built and maintained that backend, and Amazon, who's done various things, but especially helped build TorchServe, which is a PyTorch serving model for production. So that's just 60% of them. Like the other 40% is actually people who are not affiliated with any particular larger entity and the core open source developers. And actually, one interesting stat is like 13% of PRs came from people who contributed, this year. So like the community remains in a reasonably healthy shape overall, and we really like the emphasis on people and not companies, and growing the whole ecosystem in within that framework. So PyTorch has a very large ecosystem of libraries that are not just like within the Python ecosystem, but also very specifically built for and on top of the PyTorch ecosystem. And you can look at more of that on our website in the ecosystem tab. One thing I mentioned is like, we've focused on researchers and production, and research was our initial emphasis on PyTorch, and over time, our principles grew into stability and production, similar to Julia, I guess. And over time, we have seen substantial growth in machine learning research, and that remains strong and consistent. So that's the rough 15-minute overview about PyTorch as such. But I think that's not useful to anyone else who's starting their own open source project, either in the Julia ecosystem or otherwise. And I wanted to talk a little bit about the journey of both PyTorch and myself, but mostly PyTorch, and where we came from. And here, I want to structure the next 20 minutes or so that we have into 4 topics that cover 4 to 8 stories, and cover, depending on the time I have, about 4 embarrassing moments for the PyTorch project, or funny moments for the PyTorch project. So I want to first talk about a little bit of just where did we come from? So in open source, I think we generally start building projects out of interest more than saying, oh, we need to build this product that needs to have 10,000 users, and how do we get to 10,000 users? That's just not how open source really builds. It's more organic. So when we start in open source, it is out of personal interest, or we mostly try to intersect it with something that's of broader interest or need. We say, oh, I'm interested in this thing, and then this other person is interested in this thing, or I'm interested in this thing and I know I can do it well, but then there's this larger community that needs this thing, so maybe I'll build it for the benefit of all. The market making here is a bit of organic, self-fulfilling prophecy, where in open source, you grow ideas and projects only if they're of interest to many other people who want to commit time as well. There are rare exceptions. So there are exceptions where open source projects start as mega projects started by some large, well-funded corporation, and then they just start as open source projects, but they're top-down plan. But that's not what I want to talk about here today. So in general, when you think about say joining an open source project and contributing to it, or like let's say you've joined, you start contributing to a project, or you're starting a new project and you're more experienced with open source, you think about the philosophy or principles that your project stands for. So you think about, oh, like, what do I stand for? And here, like, I think it's I want to talk a little bit through the, like, how do we think about philosophy or principles through my journey. So I started working on the previous predecessor to PyTorch. It was called Torch, and it was written in Lua. And I came into the Torch community in 2010, 2011. I was doing my master's at the time at NYU, and I needed to do neural networks. And I was using a different library at that time, but then I ran into Torch, and it was much more productive for me. And that's how I got into it. So over time, I made friends in the Torch community. I understood the implicit principles with which they operated. Open source is, I think, like somewhat similar to politics in that no one, I mean, not all open source, but like say like young open source projects, they don't define anything concretely in terms of what the principles of the project are, or what the relationships between people are. It's organic, and it's largely unsaid on how things go. And not everyone stands for the same thing on the project either. Some people might, care about something, an extreme set of principles. Some people only care about just the utility of the project and don't care about what principles the project is operating in, and so on. So over the years, I absorbed and appreciated that Torch was a user-centric product. And like this is like an important distinction, and that you can have, I think, like you can broadly categorize projects in open source into either technology-centric or user-centric. That is, like, are they trying to promote a particular idea or technology, or are they trying to cater to a set of a persona of users? And like I worked on both kinds of projects. So one example is I used to work, I wouldn't say work, but I helped on this project called Tensor Comprehensions, which basically the way the project was defined was it tried to bring polyhedral compiler technology to users. And it was very much technology centric in that, like, the identity of the project depended on bringing polyhedral compiler ideas to users. But like, let's say the polyhedral ideas didn't work out, then the project wouldn't say pivot to some other idea and say, oh, like, whatever works for the user, like that's what I want to do, because that's very much an idea or technology centric project. And that's what the identity of the project was, and that's what its philosophy and operating principles were. PyTorch, on the other hand, for example, or Torch, they are a user-centric product. Like they stood for, hey, like, we want to cater to these users. We have a core set of principles, but those core set of principles are around what it stood for in the minds of users. So we mainly operated on the principles of, like, we want the code to be immediately executable. That is, like, users should be able to easily debug the code and immediately see the results. Feel like they're in a first-class language and VM and tooling. And the project should stay out of the way of the user if they want to extend their code in some ways. So, for example, with PyTorch or Torch, the one before that, like if we wanted to write a special function that needed way more performance and we wanted to write it in C or C++, then Torch made it very easy to just bind that C function into Torch and work with the rest of Torch. And that was like an operating principle that's basically the central operating principle of the project that was important to us. And that's very different from a technology-centric principle. And so Torch, that's what it stood for. It stood for like immediate mode, easy to debug, stay out of the way, explicit product. It was targeted at people somewhat familiar with programming matters, so who could reason about things like performance, and if they needed anything custom, they would just go implement it and bind it into the rest of the code written in Torch. So when we were writing PyTorch, I thought, well, like everyone in the Torch community probably stands for like, these principles, and they probably don't have technology-centric opinions. And that wasn't true. And I found out somewhat the hard way. So for the large part, when we were thinking of writing what would eventually be PyTorch, in the Torch community, we were having a lot of discussions on GitHub and the forums and on Gitter chat. And we were talking about how, our community, the Lua has been very hard to grow because Lua as an ecosystem of the language is really small. And maybe we can take the exact same operating principles we have and move that to Python, maybe rewrite a new core, and maybe it would work better. But then we realized there were a couple of really important people in the Torch community at that time who didn't share that view. And that's the nature of open source. It's very unsaid until you say it, and then you realize that people aren't on the same page with you because everything is organic. So we had to make a hard call. So should we leave those couple of people behind, while the larger set of people, the core developers, we built what we thought was the future, or did we try to get them along, but then we couldn't find a way forward because we wanted to move forward into Python and they did not? And ultimately, these are difficult decisions to make, and I'm sure you will come to such decisions as well, where they are subjective, and there's no binary answer. There's no right answer. You just have to make the decision and move on with it and live with it. So the question is mostly when do you stay? What are your core principles, and what are not your core principles, and where you're more flexible? And then you basically just stay really stubborn on your principles, but then on everything else you can stay pragmatic and change as the wind needs you to change. So that's I think that was one really important story for experience for me, because that was the time when I realized that I had to make hard decisions on sometimes not bringing everyone along if that was what the right thing to do was from the overall principle framework that we built. And another interesting thing in that same pocket is over the years. So, and then we built PyTorch. So what we did was we took the backend of Torch, we refactored it to not have the Lua parts, and then we started building a Python front end. So Adam Pashka, who was the first author of the PyTorch paper at that time, he was in the Torch community, and He was doing his undergrad at the time, and he wanted to he was looking for internships, and we thought it was a good opportunity to, instead of working nights and weekends on the next version of Torch, that Adam came in as an intern with me and Sam and Greg and some other people who were core developers of Torch at that time. And along with Adam and a few other people at Facebook and a bunch of other people in the Torch community at that time, we slowly started building and thinking and brainstorming what would be eventually be PyTorch, and we did that in about 6 to 8 months at that time. So, but after, like, the next story is more about, okay, like, so we built PyTorch, and then we started, like, whatever principles we operated with, it started getting successful for various reasons. And then, like, we had a few opportunities where there were other communities, the Cafe 2 community, the Chainer community. They wanted to join forces. And this is a natural conversation you will have in open source, where, let's say, two projects with the same or similar philosophies or needs are competing. And they're like, if you're in user-centric projects, then you care more about competition, like user-centric competition. Oh, like, who else is serving the same set of users? Oh, there's TensorFlow, who's like eating our lunch every day, or there's Tiano. There, you think about the broader ecosystem, and you say, like, you when you're user-centric, you think about competition more naturally. So when PyTorch started growing rapidly, and it was obvious that TensorFlow was the most dominant one, some of the other frameworks at that time, we talked about how they wanted to come join into our community and maybe be a combined community. And here, I think again, this goes back to principles, is what, like, whenever, like, we had such a conversation, and we work with the Cafe 2 and the Chainer communities to bring them in to and make a larger combined community. And we had conversations with some other communities where, like, we didn't have a working model, so we said we would just go part ways. And, like, the critical thing here is we weren't willing to compromise on our core principles that I talked about earlier. But then we were willing to compromise on everything else. We were, like, willing to compromise on, say, operating models, social models, or even, like, product development. Oh, like, we didn't care that much about production, but then, like, XYZ cares about stability and production. Okay, like, it doesn't really conflict with our principles, so maybe we should cater to that, and things like that. So just be stubborn on your core principles, but everything else, is definitely an opportunity. And be kind to your competitors, or, like, because they, in the future, they might want to come join your community, and that might just be for the benefit of your community, because the larger the community is, the larger the community effects are. So I think that was generally what I want to talk about in terms of philosophy and principles. And then I want to talk a little bit about the topic of scope and risk. So one thing that I want to clearly acknowledge here is when we were Torch and we were starting to think about PyTorch, we were very small. We were, I think, the people who ended up actually spending nights and weekends building PyTorch was about 18 people or so. But, like, in terms of actual, let's say, full-time development, you could think of us, say, having about 4 or 5 engineers, like, who, like, in aggregate, who are doing full-time development. That is, like, we come on all the part-time people who are working just on the nights. then like, can you aggregate their time and you make them all like, multiple of them into one single person, then like if you aggregate all these numbers of people, I would say about 5 people built PyTorch overall until its launch. We were facing a very formidable competitor at the time, TensorFlow, and like from various rumors. I mean, we didn't know directly, but from various like rumor, like asking friends at that time, we heard they had 10 to 30 times more developers than we had. We were a small attempt at trying to survive the future. So the one advantage, I mean, not advantage, the really nice thing for us that really worked out was TensorFlow was trying to be everything for everyone. Like they were trying to take the entire market of AI and machine learning and all that. And it was a project that was planned with a big vision and top down, and like a huge amount of resources and breadth. So we naturally thought about both the scope that we wanted to compete in and the risk that we wanted to take. We wanted to go the exact opposite. We wanted to put our energy into a much smaller pie, but then do that pie really, really well. So, and that was actually, realistically the only way for us to survive and compete. So we would concentrate on no one except ML researchers. That's how we started. We wanted to just concentrate on them and then make their life really good. This way we can stay focused and deliver with less resources. Here I want to talk about the type of risks you take. And we were making a deliberate bet on the ML researcher market. And we were making a bet that the ML researchers market will be expanding, and the kind of modeling that they were doing is going to need more flexibility and debuggability. Either of those things could have not been true, and maybe ConNets were say ResNets was the last breakthrough in ML AI research, and then all you needed was something like ResNets as a package, and then like that would be the end. Then we would have still existed, but like we would have been much more niche than we needed to be. But like the bet that we took was that modeling in ML research will be more flexible and more debuggable, and those needs will keep growing over time. And I talked a little bit about this in a different talk I gave at Scale AI, and you can if you're interested in that framework, you can go listen to that talk. And that actually worked out. So, and part of our success, or maybe a lot of our success, it's hard to tell which, because it's hard to do counterfactuals. It comes from the fact that we made that bet and that bet worked out. And by success, I mean we grew to a much bigger scale than we actually expected we would. And we didn't make that bet honestly by thinking, oh, how do we become big? We just were like, what do we care about? And most of us were researchers at the time, and we said, we care about ourselves. So let's just build something for ourselves. And then it just so happened that that need expanded over time. So in terms of scope and risk, if we took a different pie that wasn't as important, or if we didn't take that risk of going for that long-term market and hoping that it would expand, we would have probably stayed with 5 to 10 core developers, a small niche community. And that is fine too. That you're still happy. Open source is not about it's not about growing. It's just about, are you doing what you feel like doing? But we wouldn't have had this kind of expansion, and we probably would have just gotten killed over time by someone as large as TensorFlow at that time. However, that's not where we just ended the scope for PyTorch. Once we were successful in research, and as we started talking to other communities who wanted to come consolidate with us, we increased our ambition. We basically incrementally expanded our scope and ambition as the size of our community grew and matured. And this is the whole bottom-up growth. You just grow incrementally ambitious versus you have like a top-down crazy plan and like a lot of resources, and you want to grow top-down from them. And like instead we grew bottom-up, we made small bets, we see if they worked out, and then we expanded. And I think that's like another area where if you have a framework on why you're taking certain bets or like what scope you're attacking, you'll have a much more clearer head in concentrating your resources, which are finite. The third thing I want to talk is about measurement. So generally, and again, this goes back to story time. In our Torch days, when I became the lead maintainer of Torch, and like also, was engaging a lot more with the broader community on Twitter and like social media, we learned a lot about how people love to measure things and how other people love to read comparisons of these measurement as if it was gospel. Even if the measurement was incredibly flawed, like it's like once you see some numbers and some measurement, it's like the eyeballs just go there, and people think of those measurements seriously. And then because we like by measurements I mean micro benchmarks or GitHub stars or some tables of comparison comparing one product to another that is like super noisy. We kind of felt wronged when we were on Torch because a lot of the measurements we felt were unfair to us. So we were always antagonized by them. We were always reactive. And the big realization we took out of our experiences from Torch was to ask ourselves when we were building PyTorch, how prematurely measuring something and caring about that measurement, whether you measured it or someone else measures it, if you care about that measurement, how it shapes the product. We spent a lot of time reactively, like, fixing our, say, performance specifically to like a given micro benchmark that someone else published. And like we knew those measurements were not great and noisy, and yet we were defending ourselves. And like this is something that really shaped our philosophy here on this aspect for PyTorch. We were clear that our core competency of usability and debuggability is not something that's measurable like speed or some other statistic. But the buttery smooth user experience that puts flexibility, API design, and debuggability as a top priority, that's something we cared about. Just because it's not measurable doesn't mean it's not important. Maybe it is the most important thing in the room. And so we had to get really comfortable with this ambiguousness. And I think I'm getting close to running out of time, so I'll keep it short here. But like PyTorch never published a benchmark that is comparing itself to anyone else, any other product. We never submitted to industry benchmarks like MLPerf. And the only measurements we kept were extremely long-term measurements where like you can actually measure that someone has used your product. Like they actually say import PyTorch, or they actually cited you in a paper. And that had a big lag. And that's okay. Like, we were, and like, how did we actually end up measuring? And this comes to both, the last point is I like the way we were measuring was like I would actually sit and read through every single GitHub issue, GitHub PR, forum post, Twitter post, Hacker News post, Reddit post, every single day. And out of consuming all of this information, I got a good signal of where we need to reprioritize ourselves. And this is like not scalable. And actually, that ended up being a problem because I was incredibly burnt out because I was like reading 500 notifications a day in addition to like a bunch of forum posts and so on. So we couldn't scale this measurement. And by the way, that's pretty much what I want to talk about. Like, don't be afraid of measurement, of of aspects of your product that are unmeasurable, they're probably still important, probably more important than you think. So the last aspect I want to talk about is scaling. There's three things I want to talk about here. The volume of information. And I'm not going to spend a huge amount of time here, but like the summary is, I didn't scale the process up, but at some point I was burnt out and I said, I can't do this anymore. And Edward Yang, who's my colleague, he took over the process and he said, I'm going to take over the process with a deliberate intent of trying to scale the process. And then he wrote a beautiful blog post about it that you can go read. But it roughly, that's partly why even at our scale, we're able to have 100% read rate on the issues and PRs that we have as of today. It involved building some tooling and such. So the other thing I want to talk about on scaling, and then I'll go to questions, is two things. One is like you're going to come to a point where you want to figure out whether you want to do vertical integration or horizontal integration. So you can think of like, for example, how like I have this story from 2009 where AMD spun out their fab, their chip design, their chip fabrication to a completely separate entity. And like, there was some article I was reading that said it's because the chip designers and the fab people weren't working very well. And like this comes to like, if you can do vertical integration, you can have a monorepo for your ecosystem of project and so on. Or and that might work well. For example, for the case of Apple building their M1 chip and optimizing it all the way through their software stack, and they're seeing outsized returns. When it works, vertical integration works really well. But when it doesn't work, it hinders your whole project. So when you're scaling, you need to think about whether like it's whether you want to horizontally scale or vertically scale. And that's a function of how your team is built, where the team works, how the team communicates, and so on. So and like it's important as you scale to also communicate your principles and onboard people. And that's another really important aspect that I think we haven't done it as well as we would have liked, but we are improving over time. And this is an aspect that I think scaling is an aspect that most of you won't run into, especially in smaller open source projects, but it's worth noting down. And so like the closing thoughts that I have, and actually it's probably a good time to go into questions now. Should I just pick the top couple of questions, Saranjit, or do you have any questions that you picked that I should answer?
Oh, Saranjit, just feel free to pick a couple of questions and ask Soumith.
Okay, so I'm gonna pick something interesting. So like one question is, do you see TorchScript becoming an independent programming language? And TorchScript, by the way, is a subset of Python that we defined to make optimizing PyTorch programs easier using our JIT. I don't think so. Actually, we've been thinking about going the complete opposite direction of saying, does TorchScript even fit within our philosophies? Because TorchScript is trying to fit a DSL, a graph DSL, into PyTorch, and we're like, well, like I don't know. And so like I actually don't think so. I think it's probably the opposite. We're thinking about how we can bring Python closer and more performant to where we need it to be, and how we can do graph-like optimizations within the Python framework than trying to restrict Python and having users dealing with this problem, like with that substandard user experience you get from that restriction. And then, yeah, let's see.
Can you pick one last question, Soumith?
Yeah, I think so. I know it is PyTorch, but do you imagine having first-class frontends for other languages such as Julia? Absolutely, I think so. But the fundamental part here is we really go after users. We are a user-centric product. So, and I've talked about this in my other talk, where I talk about the future of the ML framework industry. But like the TLDR is, there's a huge energy barrier we need to cross for the machine learning ecosystem to try to move away from Python to another language. Either that comes from like there's a completely different set of models that actually are more suited to Julia and not suited to Python, or something of that sort. And if and when that happens, whether it is Julia or some other language, absolutely, PyTorch is like really about keeping up with the users, and so we will move to wherever the users are. Thank you so much for all the time I've been given. And if anyone has any other questions, feel free to email me or just get in touch. Thank you.
Thank you for the wonderful talk, Soumith.